All right, so we'll go ahead and get started. Welcome everyone to the June member spotlight. Today we are going to feature Nano Discovery. And Trina, if you can change to the next slide, we'll just go over a few housekeeping items. So your audio line is muted, so please keep your questions until the end of the presentation, but feel free to put those into the chat or the Q&A. Use the Q&A to enter your questions, and then we will be recording this webinar and it will be posted on Exchange soon, as well as we will have a blog to accompany it. And then slides will not be available after this webinar, but again, you can check out the recording or the blog on the Exchange site after this webinar, and we'll let you know when that's available. Trina, if you can move to the next slide. All right, and so I'd like to introduce Dr. Trine Hua. She is the CEO and co-founder of Nano Discovery Inc. Nano Discovery is a biotechnology company based in Orlando, Florida. They develop, manufacture, and sell rapid blood test product, D2DX, immunity test, to detect and monitor the immunity status and health of farm and companion animals. The technology was developed at the University of Central Florida in Orlando, where Dr. Hua is also a professor in the Department of Chemistry and Nanoscience Technology Center. Dr. Trine Hua, thank you very much for being with us today, and I'll let you go ahead and start your presentation.
Oh, well, great. Thank you, Nico, for the kind introduction. And I also want to thank Niamre for the opportunity to make this member spotlight presentation. And also thank everyone for coming to this presentation. So Nano Discovery, we're a small startup company. I hope to take the opportunity today to tell you exactly what we do, what is a D2DX immunity test. So far, actually, the test, as you can see, all the animals I presented here, including here, that's actually what the D2DX immunity test has already been applied to here. So as Nicole mentioned, we're located in the city, beautiful Orlando. So we have a lot of fun here, except the summer is a little hard, of course. Yeah. So now I'm going to get to the point. Of course, I guess the entire audience here knows exactly very well about this, the importance of this slide. So as we dealing with, I guess most of the proper farm animals, down to the bottom, we're trying to really to avoid the, if possible, avoid the diseases, avoid all the medical costs and everything, and they improve the productivity and the reproductivity as well. That's what really counts. So to do that, even basically we all know immune health when it comes to the animal disease, basically infectious disease, probably is the biggest problem there. So as we know, as like for animals and humans, and definitely better immune health will help us to, get through or avoid the infectious disease, I guess, after COVID-19. We all know about this now. So in order to do this, of course, companies, academic researchers, everyone is doing what they can using different approaches from genetics breeding, from the nutrition supplements, vaccination definitely is to improve the disease resistance management as well. Now, eventually, of course, some animals will get sick and you do have to use antibiotics. But the point is, I know, my slides, as you can see, really from today, may not be appearing directly associated with antimicrobial resistance, but it has everything to do with it. Because why do we use antibiotics? Because animal got sick. And if you have a better immune health, obviously you will have a less disease incidence, and you can use less antibiotics, as we all know that. So here is a brief summary about the D2DX immunity test. It's actually a really simple test. You could use it on farm. We call animal side. but you could actually do it just by the animal side. So the test is very simple. As you can see this illustration here. Take the blood. We can do blood serum or plasma. So if it's a plasma sample, you don't even need to spin it down. And the test basically has one single reagent and one small device, which is look like almost just a little bigger than a cell phone. So the test basically you can do this on the farm. You don't have to send it out to the lab. So it could be done by a trained staff in the farm or veterinary doctors. Draw the blood, do the test, and you can use the test results to make management or treatment decisions. So I am proud to say, yes, indeed, our product is one of its kind of products. So probably that is also, I appreciate the opportunity to, introduce this product to the producers, to the researchers as well. So one thing I do want to highlight the results. Actually, the whole thing takes 1 minute to run and to get the results. So this is the advantage of the test. So now, actually, we do have a video demo. If you actually be able to click it, not so sure, but you can actually download the brochure from our company website, and then you can actually get to the link as well to see how the test is really formed. So I'll give a little bit of scientific background, exactly what this test is about, what is detecting. So this is a link which actually original publication is, where D2DX based the principle from this publication. So basically in this test, we have a key reagent, which is actually, I can tell you probably the little secret, is made from a gold nanoparticle. Actually, indeed, it is gold. So, but this little nanoparticle, it's made look like a fake virus particle, but it doesn't have really any of the biological activity like carry the RNA, DNA, do anything. It's actually classified as a non-hazardous chemical material. Okay, but they look like a virus particle. So when you mix it with the blood serum or plasma sample, as we know what, of course, the blood serum plasma samples has all the humoral immune molecules, the ones like we know very well, IgG antibody, probably less, mention about the IgM, but then probably less mention about complements, but certainly cytokines. So now what happens is when you mix them together, actually the blood serum plasma is a biologically active material. So it sees that this is a little particle, even though it's not a real pathogen, but it think it's a pathogen. So the immune molecules will start to react together interact with this little nanoparticle pseudopathogen. So the consequence of this reaction, actually this reaction very much mimic the in vivo, we call what's happening in vivo, the reactions. So the immune molecules like the IgG antibody, IgM, and the complement, actually they can have a set of very complicated reactions around this nanoparticle pseudopathogen, and then we can actually clump them together. Then these bigger clumps will be taken up by the immune cells, macrophages, neutrophils, and then processed, and then that process leads to the adaptive immunity. So what's a unique thing about this reagent, nanoparticle reagent, is the change color. So before, at the beginning of the reaction, it shows one color. By the way, this is literally really the color of the reagent. And once the reaction occurred to a certain degree, it changes to a bluish purple color. So you can use actually this this device called CD100 is basically a colorimeter device. You monitor basically the color change. That tells you what the immune responses is. So this is a basic scientific principle. Again, there are lots of talked about in this original article about the background of this test. So now I'm going to, Lisa, show you some of the applications as you can see all the animals are listed here. We do have data, or clients have the data. They have used it on these different animal species. So several highlights I want to point out. Indeed, the advantage of the test is indeed it's the same test. It can use on animals at all growth and the reproduction stages, from newborn, neonatal calves to cows, at any, heifers, cows to any age. This is basically for the even for the pets, dogs. We have the data from pups to adults to senior and the geriatric ages. Okay, so the immune status basically changes in the animal upon infection. So that is quite important. Of course, when you have an infection, bacterial or virus or parasites. So then basically by looking at the immune status change, you can actually see if the animal is infected. Some other we see that really is people are using, our clients or partners are using, is actually really looking the impact, I would say evaluate the impact, the quality of food, additives, product, nutrition supplements on the immune health of the animal. As we say, we all say, okay, we do want to develop, we do want to have a product that will boost the immune health of the animals. So how do we really measure it? In the lab, it's complicated, but in the farm, in the field, that is, we need a simple device, a simple product here. Okay, so this is just a immune health is also related to reproduction as well. I mean, this reproductive immunology, that's basically dealing with how the immune status affected the reproduction of the animals. So I just want to list very quickly. Here's the scope. So our clients we're still very small startup company, but we're also proud to say that we do have quite a number of academic and company clients using our product for research for their trials. So, and we do have ourselves and our clients and collaborators. As you can see, we are very active, you say, researcher, user group, using our product to investigate all different kinds of animal health related, problems, particularly, of course, related to immune health. So you can see all this on our company website. So in the next, I guess the slides, the number of slides, I'm just going to show some examples of the potential, the applications of the D2DX immunity test. The first portion I want to show really is about the dairy cows. As we know, if you talk about the antibiotic use, that's a major concern. Lots of antibiotics used in the dairy farm industry to deal with the high disease incidence prevalence there. So one of this is one of the first, I guess, that study. So you can see from the dairy cows during the peri-purulent period, a couple of weeks before, 2 weeks after. So we can see actually this is the immunity score. Indeed, there's a significant change during this transition period. So it does basically correlate to what, we all know very well, the field know very well. There definitely there's a lot going on with the immune health related to, how it impacted the disease risk of the dairy cows. So this is a paper published by Dr. Adrian Barragan. I'm a co-author there. So, same as the first study, as you can see there. So in their study, they're using Dr. Barragan's study. They're using aspirin, basically it's aspirin to regulate the inflammation of the dairy cows during this transition period. So we do see the same trends. As here you can see there's a change of the immune status in the cows during this time, but also in their finding, indeed, by using aspirin to control the, not to completely eliminate inflammation, but to control the inflammation. Indeed, it does affect the immune health of the cows. And another finding from this paper, from this work, is we see a correlation, a positive correlation between the D2DX score and the average, daily milk, the daily milk production in the first 60 days in milk. So this test was done, of course, 14 days post-COVID, but you can see that the cows with a higher immunity score, it does produce more milk. So in general, it's an indication of a better health there. So in another study, which is early on, and also find the basically you can see in terms of clinical metritis. So the cows with a higher immunity score, basically, versus the ones that develop metritis. So there is a difference between the score here. So in summary, it says, the cows with better immune health, it has a less risk of metritis. So this is just a closer look of the set of data, one set of the data you can see here. So for D2DX score, there are, of course, in a very high score. This is the scores are basically measured at the day around the day of calving. So if a higher score, you can see there'll be less, metritis incidence. Okay. So one other thing, this is a study which actually a collaboration with two different groups. So we also see the immunity. This is just an example showing here about the immunity score, how it is related to pregnancy rate, which is actually quite interesting here. So both studies, they're not, they have a relatively small size, but overall, but still, you can see that from both studies, we see the same trend. So in the high immunity score group, you can see a conception rate of 75% versus the low immunity group, 33%. And then in a different study, more or less, we see a similar differences here. So I guess this is a very small study, this two kind of give, a sense, just to say indeed the immune health will affect the reproduction performance of the animals as well. So next one, I will switch to the young animals, dairy and beef calves here. So this is one I would like to show. It's actually, the study actually is done by Dr. David Casper from Casper Calf Ranch. So it's actually quite a number of samples tested here. As we know, the dairy calves, of course, they are really the ones which face the most challenging during the first few weeks of their life. So lots of health issues, diarrhea, bovine respiratory disease, and all this. So what we see is this is kind of showing you how the immunity of the neonatal calves changes. So from a few days after the birth, so because they got some immunity protection from the mother cow through the colostrum, through the passive immunity transfer, so they do have some immunity, they do. But then about we see is 5 weeks later, so they kind of the passive transfer immunity kind of faded, disappeared, and the calves haven't got their own immunity fully developed yet. So there's a very low point. And then after 5 weeks, they start to climb up as the calves develop their own immunity. So this graph basically shows indeed this D2TX test really can catch the immune status change development. Also, of course, we're mainly referring to humoral immunity here during the early stage of life development here. So one thing though, I want to highlight it here. This is another study by Dr. Kasper. It's a different one. So basically, as we know, scalds is a big issue in dairy calf. So you can see his data actually shows that there's a data shows the newborn dairy calves. The test was conducted a few days after after their birth, and just arrived at the calf ranch. So you can see that the higher immunity score group. So for example, this morbidity length. So the ones that didn't need a treatment for scald or just one treatment versus those who need more than 5 days of treatment. So you can see there's a significant difference here with the immunity score. So the calves which had the better, higher immunity score, as you can see, they did better. And then in terms of mortality, you can see even a bigger difference here. And the 5 calves died during this time. So overall, their score is much lower than the calves which survived. So again, I say, of course, the calves got sick or died later in the ranch, but then the test was done upon the arrival at the ranch. Okay, so another couple of examples is about this. I can say now it can be used to really evaluate whether certain supplements product boosted the immune health or not. This is from some research studies, as you can see, with certain supplements, the treated group in both actually they show improvement on the 4 weeks old calves. Yeah, and this is just another study, another trial. As you can see, after the treatment, you have calves basically treated the one. You have the calves. Remember those calves, their scores are very low because it's all few weeks old, of course. But then with the effective, I guess, treatment, you can boost the calves with a higher immunity score. So this is one study, is a collaboration between with Dr. Chateau, investigating heat stress on how the heat stress affect the immune health. So indeed, as even we know that heat stress is really not good for the animals, especially young animals. You can actually see that the heat stress group, actually the immunity score decreased faster than the cool group. So this is about also neonatal dairy calves, upon basically about two weeks old, for during this time. So this they did also see, of course, after the challenge, BRD challenge, you do see some immunity difference as well. This one was actually the data partially presented by Zinpro. This is on the actually beef calves. So this beef calves basically is they went to feedlot. So those I want to point out over here is those 3 batches from a different truckload. So we can see, I know there's a lot of mysteries associated with this exactly, when the calves are, at a high risk, they'll get sick. So still really a lot of mysteries there. And for that, of course, we all know feed-a-lot calves use a lot of antibiotics, as a prophylactic treatment to deal with the disease later. So there are lots to be learned. So for using D2DX, we can see there's a big difference from the different truckload. You can see that all these calves are very similar age. Basically, You can see that the ones, particularly the ones I'm pointing now, definitely, even though all these cubs are the same age, but this one clearly looks like they experienced some significant stress for whatever reason. You can see that the immunity score just dropped almost to nothing, to baseline level, while you have the good ones, which this is actually the normal one. I don't have all the, cannot show all the data here. Quite a few other studies kind of confirm this is more or less the normal score range here. So this is again another feedback study which is already published actually by Zimpro and also a research group at the Iowa State University. So what you can see that interesting thing again. So yeah, here this is what I want to show you. The calves just arrived at feedlot. That's the average score. And 2 weeks later, there's actually a increase. And then 42 days later, there's decrease. Now, I'm not going to make too much out of this data here for now, but instead just to point out, the immune status in the animals really change a lot with the environment change, because they change from original farm now to feed a lot. They have a new diet as well. So all this will impact the immunity. How does this exactly affect the disease risk? And of course, there needs to be more study over there. So, and I would say this is similar results, similar finding actually was just reported, it was presented, I guess, by another research group from West Texas A&M University. Okay, so I switch now a little bit from cattle to a sheep and a lamb. So very similarly, so I'm gonna just show the data very quickly here. So those are the mother ewes, adult animals during the pari-paturation period, 40 days before lambing and 30 days post lambing. So if I point this out, of course, if you still remember the transition cow. So clearly that's a completely different trend. So, the cows, they before calving, they go from a low to high and then drops down to lower. But then for lamb, for the sheep, and actually it goes down. But then it started to, seems they're recovering, although not so dramatically. But you can see that just between, though, yes, they're all ruminants, but we all know there's a big difference between sheep and the cow. But you can see that their immune status, humoral immune status, what a big difference, we can find from there. So young animals, on the other hand, the lamb, the newborn from 3 days post-birth to about 60 days, as you can see, really, there's a significant variation change also lamb. So for the lamb, they actually immunity score was very low, and it goes up and then stables down. So again, immunology is I would say extremely complicated field. So I will not, talk going through too much about what this is about. How do you, interpret the data? If we have researchers in the audience, I would love to, if you want to reach out to me, and I'm always looking for academic collaboration, exchange ideas. So for here, though, I'll stop here. So then, of course, the immune health is related to diseases. So for sheep and the lamb, we're mainly looking at the parasitic infection. Over here, look at the parameter of fecal egg count here. So you can see roughly there's a trend, there's a negative correlation between the immunity score and the fecal FEC. So yeah, so higher immunity, lower FEC, lower immunity, then you have high FEC here. That's for the U, and this is for the sorry. Now this is another health parameter. This is milking dairy sheep. So we look at the SCC, somatic cell count of the milk. So you can see that the D2DX score also correlate to SCC. So the ones which is healthier has have a better immunity score than the SCC numbers are lower. There's also some correlation between the mother use health versus the lamb's performance, immunity, and the average daily gain here. So about the infection, so this is a very nicely done controlled challenge study, which basically they use will challenge the intramammary, mimic the intramammary infection with this a bacteria. So you can see that how immunity score changes. So actually, so upon the challenge within about 48 hours timing. So you can see actually the immunity score decrease. So I know people ask me saying, oh, there is an infection. Why isn't the immunity score increase? Actually, this is more complicated because the infection is basically occurring at the mammary gland. So it will be in the mammary gland actually mainly relies on neutrophil to deal with a bacterial infection. So neutrophils actually don't just act alone. It actually requires other immune molecules, antibodies, complements, actually special complements. So the complements all those immune molecules which basically will be transferred to the mammary gland, gland area to help beat with the fight against the infection. So as a result, those active immune molecules in the blood actually decrease. So we do see commonly, yes, the immunity score will decrease upon a infection here. So this one is the data I'm just showing you very quickly over here. So it's on poultry as well. So this is a little bit of different study. So, but again, we do see the difference. That's a key point between the different groups of animals. Okay. Finally, I guess I'm getting close about the pets. So this is a one study by Four Rivers Canine. So interesting, you can see that basically the immunity score of this D2DX, correlation with how it changes with the age from the canine samples. So indeed, puppies, when they were young, they were low immunity, and then they started to increase. But then you can also, once you get to senior, geriatric age, they actually kind of decrease, but I wouldn't say it's such a uniform decrease. But you definitely see some things, the immune status getting quite a different, more and more different. Some goes quite a lower, and some goes higher, very high. So so this is about the canine, the dog. So they do have Four Rivers will present this results in the upcoming ASS conference. The idea is, again, want to say all this immunity study so far is to understand really to have a simple routine tool to check really the immune health, immune status, understand all the factors might affect all these different animal species. So I guess I could also present a little bit, tell you a little bit, even fish, manatee. That's what actually an active project I'm working with UFO, Dr. Yano now, aquaculture. So it's kind of interesting. This is actually from a tilapia, by the way. So they were looking at the handling the stress, how they affect the immune status. So we all know the stress, of course, but then again, to what the level, exactly what the condition, all this, different management, style, protocols will affect the immune health. So this is what we can see. And then finally, let me please allow me show you very quickly about the human. So this is actually COVID-19. So we did the study that was actually paper published while COVID-19 was still ongoing. So they are actually very similar, humans, animals, I guess, particular mammals. So you can see the normal, healthy humans. That's the immunity score is about 0.06 at this level. But then when you look at the COVID-19 patients, actually the variation, first you probably notice that is huge. Indeed, it is. So you can see all these differences here. But then if you count all these three different healthy groups from different sources, the more or less ranging in this narrow range. But then, of course, you look at these three groups, the ones without any symptom or only mild, the ones with moderate symptom, and the ones that develop severe symptoms. You can see some of the scores went down to very, very low. So see how this changes. Now, the people also ask you, oh, you still have some high ones. So I do want to mention also, because that was this difficult time. So we couldn't really record the patient's history so clearly. People say, I was sick. So we say, were you 3 weeks sick starting 3 weeks ago, 4 weeks ago, 2 weeks ago? It's not that clear. So some of the patients already recovered, on the path to recover. So you can see, but just so nevertheless, you don't see such a low immunity scores from any of the healthy controls. So along with the one I showed you about the mammary gland challenge with the bacterial infection, so you can see that the active infection will be reflected in this immunity test here. So I think what I want to is emphasize, giving you just two quick take-home messages. You can see we have indeed lots of data to show that the test indeed can check the immune status of different animal species. I do want to, of course, you would like to get down to more detailed scientific details, saying, oh, all this time I was talking about the humoral immunity. And we all know immune system involved the cell-mediated immunity. So we say you're not detecting any cell-mediated immunity. That's not true. Actually, very much they're all connected together. So it's quite a comprehensive view about the immune status. I'm not going to say it covers everything the test, just like I didn't want to people thinking, as normally we know, oh, let's check the IgG. If the IgG of the animal is good enough, that's good in immune health. In some ways, yes, IgG is a representative, indicative, good indication of the immune health, but by no means IgG is a single factor alone, because it complements all the many other factors. So extremely complicated. And I'm very, I guess I'm quite proud, and also the unique thing about tests, if you consider D2DX is a simple routine, could be used for routine monitoring of some of the critical aspects that involved in the animal health from an immune health point of view. Okay, so finally, of course, I do want to say, even though I did not really present any data to you regarding antibiotic use or something, but I hope for one, really the purpose, why are we here talking about the immune health? All the purpose is, do we have a better product? Do we have other better ways to help animals to be healthier with better immune health, so they don't get sick, so they don't require such, I would say, extensive use of antibiotics. Indeed, that's one of a major goal, you can say, we want to accomplish. We want to contribute to the industry. So, okay, so this is our contact information, and I'm happy to, as I said, here is you can send the email to me or to send it to the general email in our company, and I'm happy to, which is I work as a just to say last minute work. I'm a chemist by training, but I have been expanded really a lot, working with a lot of, I guess, biomedical researcher, immunologist. The co-inventor of the test actually is an immunologist and my colleague. And then I'm always open to collaboration to learn and to deal with whatever problems we have to deal with. Thank you.
All right, well, thank you, Dr. Tweenhalt. That was great. We do have quite a few questions. So our first question is, where can I purchase the test?
Oh, good question. I like that one.
Yeah.
So if you go to our company website, you have the contact page. We do that. Just send the email from either the company website or just send it to here, and we'll have someone take care of you. Yeah.
Great. And can the test be used to guide the usage of antibiotics on infected animals?
That's an excellent question. Now, we haven't really looked at the antibiotics ourselves, but I would say in the upcoming ASAS meeting in Calgary, in Canada in July, actually Zinpro will, who's our client, will present another study regarding the the feed-a-lot of calves, who got approved for potential treatment or not treatment, or like that. So they were using our test together with the other practice to better determine, how serious is the calf really sick and something. So they are actually presenting some data over there. Now, as for ourselves, I would love to anyone who, have thoughts or interested in collaboration. I would be more than happy to talk to you about this.
Great. And our next question, could your test potentially have applicability to detect cancer in companion animals?
Oh, that's a good question. Actually, interesting enough, in a study conducted by Four Rivers Canine, they actually did. They included some dogs with cancer. So actually, we found some amazing data, but unfortunately, that was only one dog with cancer. So I'm not going to say too much about it. However, I do have another potential collaborator. We will be testing more. We're gonna start from a dog from a dog in a month or two. If you actually search my publication record, actually I did publish several papers related to not the same test, similar tests for actually cancer diagnosis detection. That one was related to prostate cancer. Yeah, so I've always putting, the reason is indeed, as we know, actually, a there's so again a lot of unknown, but then cancer is a common, I guess, recognition, you can say, closely related to the immune status. So immune health of the person. Yeah.
Great. Our next question, outside of things like drying off, does an animal's immune change over time? Could you use this test to help make management decisions for when animals may need to be removed from production?
Oh, that's a great question. That is, I would like to get the people to do. I actually already seen. So one is as we know, the dairy cows lactation number, right? It goes to beyond the 3 and the 4, goes beyond the 4, then you get to, I guess a little nervous now. So are we keeping this cow or we're not keeping the cow? But sometimes we know the older cows actually they do have advantages. They produce better colostrum, more antibody protection, right? However, if the cow reaches to that age, many cows actually maybe their health is declining. By the way, I didn't present here, but we do have quite a lot of data showing the lactation number change. So lower lactation from 1, it goes to lower, and 2 or 3 reaches the peak, maybe 4 getting to 4, but from 4, it start to decline. So then you can say, okay, some actually are still very high, but some started to decline. Say, should I actually remove the ones that is really immunity decline, coupling with some other information? As I would like to say that's what we want the test to be useful. Another thing we're doing right now actually is also focus on a dry off, which we have some data. So the idea is before the calve and during the dry off time, if we do the test, we know just supposedly we know the risk of mastitis, metritis, and ketosis. That's actually the 3 disease conditions we'll look, because those are the 3 clearly have related to the immune health. So if we know that, that could also affect the impact of how you use antibiotics treatment. Right now, you use all blanket, everything, everyone get it. Is that necessary? And also, there's a high risk cows there. So maybe there's some product, some other measure you can take to help the cows avoid the problem post-COVID.
Great. Next question, has the D2DX test been used to help prevent BRD in animals that may be more susceptible?
We haven't looked at that. We don't have a lot of data on that one yet. I guess the BRD, one thing about the study right now is, say, I guess we're maybe talking about the dairy calves or the feedlot calves, not the ones, I guess, most impact there. So we're still evaluating the dairy calves. For the feedlot, again, we would like to look at them more, but one of the issues is right now, because the feedlot calves, pretty much everybody will try to use antibiotics, if I'm not mistaken, so far. So that basically makes the trial is a little harder to know exactly what's going on. There's also vaccination, keep that in mind. So indeed, yes, there are many unanswered questions. But again, I come back to, having a tool to regularly check really the immune status, and also looking exactly what the factor is causing the problem. I guess that's important.
Okay. And our next question, I've heard about the potential to use gene editing to create food animals that are resistant to certain diseases. Can you comment on how your test might be able to be used to ensure that gene-edited animals maintain good immune status?
Oh, that is a very interesting question. Yes, I'm very aware of the gene editing. First of all, the gene editing usually is to target it. When you do any genetic breeding gene editing, you're targeting a specific gene. So you must know which gene caused the such a problem. Just like the breeding the dairy cows, selecting which cow is going to produce more milk. That was the focus, then. So you have to know which you want to look for the disease as well. So you do look once you found it, you say, okay, great. Chances are you will find that gene, you are able to edit it. It will resist such disease. But it's, to my understanding, currently it's difficult to go You have to do editing many things to resist many diseases. The reason is simply because the immune system is complicated, involves many molecules, cells as well. So it's hard to say, oh, which one is gonna, somehow get solved. But then what about the other disease? And then again, then you come to immune health. So if this genetic editing somehow affected the immune system, then yes, then I think for sure it will affect the immune health. But if you want to, I guess it may not. As I said, yeah, it's a good question. And unless you tested it, you will not know, right? Yeah. So there's a risk there. Yeah.
Okay, and then this will be our last question. Have you done any work on the immune status of animals after vaccination?
Oh, yes, I just finished it actually with Dr. Tao. We're looking at the data. So the vaccine, I'm not able to share the results. I can tell you the story. So basically, it's on the dairy cows. No, sorry, dairy cows dry off. That's what we are looking at about the vaccination before the dry off, or about 10 days before the dry off, or just before the dry off. And indeed, we see a big difference following the vaccination. So one treatment, you will see roughly, I can tell you just on top of my head, about the 4 to 7 days average post the vaccination, you see the biggest change there. But we also see what we can see, this is preventing, so the usual vaccine for E. coli, for based mastitis, and to help the colostrum with the scale, prevent what is a black leg disease and this. So 3 different vaccines. So I do see just so far the ones that did not respond to the vaccine, it is the one appears to have the most disease so far. But we can definitely interested to get more data from there. Yeah.
All right, well, thank you very much. We appreciate everyone who joined us today for this member spotlight. Join us next month where we'll feature another member. If you have any more questions or you'd like to collaborate with Dr. Trinh Hua at Nano Discovery, please feel free to reach out to her. As indicated before, we will have this presentation available on Exchange, so stay tuned for that. Have a great day, everyone.